All right, folks, we're doing examples Rajul, number 15. And now we're going to start working with identities. And identities are a little bit different than expressions in that they actually give you the answer on one side, because what we're saying on this examples number 15 is that this must always equal this. And you're kind of told, yeah, this definitely works out, just prove that it works out. So with identities, it's actually very important that you show all of your work so that people can understand how you got from one spot to another. So we're going to start using some strategies for identities now. So if you were to look at your guidelines, some of the guidelines that you want to consider very important, other than the ones that we've already gone over, is when given an identity, use only one side officially. This is a rule, not a guideline. So what you're going to see is when I start working on this number 15, I'm only going to work on one side. So don't work on both sides simultaneously, because this is kind of like a proof. So you have to be a little bit more cautious with this. Okay, this guideline is choose the worst side of the identity, the crappiest side to work on. That way you can make it look pretty. Okay? And that's actually, there's a lot of relevance to that. So out of these two sides right here, it looks like this is the worst side. So I'm going to start with this side as the side that I'm going to try to work to get to equal this side. All right, so if you get stuck on the identity, go to the other side. So if this side isn't going to work out, you're going to see that I'm going to switch over to this side. But I think that the bad side is probably going to work out in this case. Now, I just told you about this rule where you can only use one side of an identity officially. However, say that I do get stuck over here, and we might, then I'm going to secretly work on the other side, and then I'm going to write my work backwards. And you guys are going to see how I'm going to do that on this problem. And then finally, use the other side of the identity to guide the side you're working on. So we're going to do that as well right now. So as you can see, I'm going to work on this side of the identity, but I'm trying to get this. And I can see that I don't have any separation here by addition or subtraction, but I do have subtraction here. So that means that what I want to do is I want to combine this fraction, which is what we've been doing when we've been doing expressions. So let's go ahead and do that now. We're just going to work on this side, and we're going to pretend that this is an expression just like it always was. So I'm going to go ahead and rewrite this just so I've got a little bit more room so you guys can see what I'm about to do. Some of you guys can probably guess at what I'm about to do here. And for those of you who guessed it, I'm going to get common denominators. So this is going to be 1 plus sine x over 1 plus sine x. And here I'm going to have to multiply by 1 minus sine x over 1 minus sine x. And this is going to give me 1 plus sine of x minus, and be very, very careful about this. Here's a minus sign here, and keep this in parentheses. That's 1 times this thing. 1 times this thing is just this thing, so it's minus the quantity, 1 minus sine x. And then remember, we're going to have to multiply that through in just a little bit. And that's over 1 plus sine x times 1 minus sine x. This is going to become 1 plus sine x. Now we're distributing that negative sign, so that's going to be minus 1 plus sine x over this denominator right here, which is going to use difference of squares. So we've got a plus b, a minus b. That's going to turn into a squared minus b squared, where a is 1 and b is sine of x. So this is going to be turned into 1 minus sine squared x. Let's go ahead and rewrite that. All right, let's shrink this down a little bit so we've got a little bit more room. All right, so we can simplify both the top and bottom of this expression, so we can see that these 1's are going to be eliminated. We have 2 sine x's on the top, so let's write 2 sine x over this bottom part, and take a look at this bottom part. That bottom part is, that denominator, is a Pythagorean identity. 1 minus sine squared x is cosine squared x. All right, now let's pretend that we get stuck here. I'm feeling pretty good about myself because I've got a 2 right here, and as you guys can see, there's a 2 on this side. So I'm pretty close to my answer, but let's pretend that we get stuck here. And a lot of students do get stuck here their first time. So secretly, I'm going to work on this other side, and I'm not going to tell anybody. So on this other side, even though I'm going to erase all of this work, and you might want to just write, like, this isn't a side, don't show this to anybody. So let's go ahead and simplify that side a little bit and see if we can't get to some sort of a middle ground. And then we're going to use that to our advantage. So on this side, it looks like I can't do very much, so I'm just going to change everything into sines and cosines. So 2 tangent x becomes 2 sine of x over cosine of x. And then we've got times secant of x, and secant of x is 1 over cosine x. Well, if I just do one more piece, let's erase that word aside. We know that we're going to erase this later. If we do one more step, that's going to turn into 2 sine of x over cosine squared x. Let's redraw that box there. Okay, so take a look. We just got the same thing twice. So here's the strategy. I'm going to erase this work that's in this box right here, but I'm going to change these arrows to go the other direction so that I end up here. So this and this are identical. So I'm going to start out here. This step goes to this step. So let's go ahead and write that down. So that becomes 2 times sine of x over cosine of x times 1 over cosine x. And then this step leads to my final answer, which is 2 tangent of x secant of x. And usually you kind of box that in, put a little check mark to show people that you're super smart and that you know how to do that. And then you just erase all of this work that you secretly did. You just don't tell anybody that you did it. And then you look like a super smart person. And that is examples number 15 on example set Rajul.